Hello, I'm Ryan Boyd, and this is going to be another brief tutorial video for the Butter software. In this video, I'm going to cover primarily Word2Vec and word embedding models in general, because I think that's something that a lot of people who will pick up the software will want to know about and want to know how to use, and it's probably not super obvious on how you can do a lot of this basic stuff just from poking around the software. So I'm going to show you how to do pretty much everything you need to know to do things with the Word2Vec plugin in Butter. So I'm assuming if you're watching this video, you've already seen the other video that shows you kind of the basics of how to build a pipeline in Butter. So I'm going to skip over all of that stuff and just really cut to the chase. So for the most part, everything that involves using a Word2Vec model or any kind of a pre-trained model in the software, I'm going to cover that in a basic way here. And this really is going to cover mostly the actual training of a Word2Vec model. And then once you've trained a Word2Vec model, you can use the file that it generates that contains a trained model to find similar words. If you've used my other program, Whelp, this is kind of the main thing that software was designed to do. You can also do the distributed dictionary representation method, and you can also get average word vectors for texts. All of this within the software itself. So in order to train a Word2Vec model in Butter, what you need to do is first build a corpus file. The reason for this is that most implementations of the Word2Vec algorithms all operate on an entire corpus of text contained within a single file. So the way that we're going to do that is we're going to take text that we already have and then build a corpus file with them. Now there are a lot of different ways you can go about doing this. What I'm going to do is, and I still have a bunch of files in here from before, what I'm going to do is take this collection of TED Talks. So each of these files right now contains a separate TED Talk transcript. And what I really want to do is take all of these files and put them in a single text file where each TED Talk is on a separate line. So the way that we can do that is we can load the text files from a folder. I'm going to add that plugin and then choose the folder that contains my text files. Then what I'm going to do is I'm going to tokenize all of these texts using the Twitter Aware tokenizer. The reason for this is that if we go back to this TED Talk, when we tokenize this text, there will be cases like this right here, where it'll split up the words talking about sexual activity, and if we don't tokenize it, the word activity is going to keep that period on the end, which is, in theory, a completely different word, or will be handled as a different word from just the word activity itself. And so we're going to use the Twitter-Aware tokenizer to split off all of the words into separate units for analysis, and the punctuation will be split off into separate units. So we're going to first tokenize, and then we're just going to reassemble everything back into a string so that we can save it to this corpus file. So again, we're just loading in the text, tokenizing, then taking those tokens that it outputs and reassembling it back to a string where the punctuation is split off automatically, and then saving it to a single corpus file. And I'm going to go ahead and name this TED Corpus. And this should run very, very quickly. Well, maybe not very, very quickly, but quickly enough. And so we can already go and see what's happening in this file by opening it up. And I'm going to turn word wrap off so that you can see every single line contains a separate TED Talk. And you can also see that the punctuation is split off, so it's separated from each of the words, so that we're not treating words with the punctuation attached as completely different from the word itself. And this should be finished in just a second. Success. And so we have our corpus file. So now we can run the Word2Vec model training algorithm. Now you'll see this is a top-level plugin. It takes a corpus file as input, and it'll output a trained Word2Vec model. Now this is kind of a special plugin. There are a couple of these in Butter, but the Word2Vec one is special in that it's a standalone plugin. It sits at the very top of a plugin chain, and you can't really connect anything to it. So I'm going to choose the corpus file that we just generated as our input file. I'm going to choose to output a model file basically in the same location. You can put it wherever you want. And I'm going to leave all of these different parameters alone now. If you know a lot about or want to experiment with different parameters for your Word2Vec algorithm, you can choose between continuous bag of words and skipgram models. You can set the number of dimensions for your vector. You can set the number of iterations. You can choose whether or not you want to use hierarchical softmax functions. But usually for most people, what it is out of the box is going to be what you want to use, or good enough anyways. So really all I did was I went in, I set the input file, I set the output file, and I'm going to go ahead and run this. And out of the box, I'm leaving this as is. The processing power is at 75%. But this plugin can use as many cores as your computer has. So if you want to do it a bit more quickly, you can turn the processing power all the way up to 100%. If you want to leave more of your processing cycles free, you can turn it down to a lower percent. I may have said this in the other video, I don't remember, but generally speaking, 75% is about what you'll want to leave the processing power at for all these plugins, just because it makes sure your computer is working hard on the text analyses, but doesn't completely use up all of your free processing cycles. So you can still run these analyses and then do other things while it's running. Check your email, watch funny videos about hippopotamuses. Do some really great ones where hippopotamuses are eating watermelons and getting their teeth brushed and things like that. In fact, while we're waiting for this to finish running right now, you can go and check some of those out. Don't worry, I'll still be here when you get back. And now once this is going to finish the model file that it's saving here, you can open this up in a text editor. And it's in a very standard format. It's a little bit different from what you may have seen elsewhere if you've used some of my other software, but this is a much more standard model format. So this first line tells you the first thing here is the number of words or number of tokens that are in your pre-trained model. The second number is how many dimensions there are to your model. So remember, we trained for 100 dimensions in our vectors. And every other line is the word, and then a space, and then the actual 100-dimension vector that corresponds to that word. So we've now successfully trained an entire Word2Vec model on the TED Talks corpus, and only took a couple of minutes. Now we can do a lot of cool stuff with this Word2Vec model. we can take it and just kind of probe it semantically using the Find Similar Words plugin. So this plugin will allow us to enter some seed words, and it'll return lists of words that are semantically similar to the mean vector of our list. So there's some examples that are already built in when you load up the settings. I'm going to go ahead and change, or I guess I'll add a couple to these. So I'll make one that includes the words science, technology, and research. I'm going to select our model file, which is the one that we just trained, and I'm going to choose an output file that will give us our cosine similarities. And just like the training plugin, this is also kind of a special case that's a standalone plugin. So we have the input file and the output file, and we don't need to connect anything to it. And so I'm going to go ahead and turn up the processing power a bit, and I'm going to go ahead and run this plugin. And this should be much faster than the previous plugin that we ran, because we're not doing anything super computationally complex. And if we look at the output here, we have a separate column for each of those word groups that we made. And if we sort from high to low, we'll find words that are similar to the mean vector for words like happy, fun, excited, and then the mean vector of anxious, nervous, and afraid, and so on. And you'd be very worried if excited was not similar to the average of these three words. So you can expect to see the seed words usually appearing near the top. And for the most part, it works pretty well. As a side note, for emotional stuff, you'll often find that negative and positive emotional content loads together. This is because they're often used in a very similar way. The same types of situations that make some people happy, you can imagine also lead to disappointment or fear or things like that. So really what you're learning from this is that emotion words are all kind of in a similar semantic space. Let's go to something a bit more obvious, like this science, technology, and research. And the similar words that we find are much more in line with what you'd expect. Science, technology, and research, neuroscience, biology, mathematics works pretty well, especially given that there's only a couple thousand texts in our TED Talks corpus that we have. Now, a couple of other plugins you can use the Word2Vec pre-trained models with are Average Word Vector, which I'm going to skip over because I think for the most part you won't need to use that one unless you really want to dig in. The Distributed Dictionary method, this is a pretty good one. So this is a normal plugin. So we're going to go ahead and we're going to go ahead and set up a plugin chain like in the other video, because we want to take a bunch of texts and analyze them using this method. So I'm going to go ahead and load in our TED Talks text files. And then what we're going to do is, and let me double check this, so the Distributed Dictionary plugin takes tokens as input. So we're going to load in the text files. We're going to then tokenize the text files. And then we're going to analyze them using the Distributed Dictionary method. And what this is going to do is allow us to choose that model that we trained, the semantic model for TED Talks. And it's going to take each text and measure the semantic similarity between each text and each of these different word lists. So the default word lists are from, I think, one of the Moral Foundation's papers, but you could just as easily replace this list with any words or word groups that you want to capture. So things like science, technology, and research. Perhaps we want to do one that is fun, happy, and terrific, and so on. And the distributed dictionary plugin gives an output array as the output type. We'll pretty much always want to connect that to the save output to CSV plugin. So I'm going to go ahead and add that, set the settings for it. I'm going to choose the actual output file that we want to generate. And I'll go ahead and analyze this. And what it's doing is going through each of the texts, tokenizing it, analyzing it using our corpus, our Word2Vec model that we trained, and then saving the output to this CSV file that we created. I'm going to go ahead and cancel this so we can just go ahead and take a peek at the output. And looks like it worked. What each of these numbers tells us, they're kind of like Pearson's correlations. It's the cosine similarity metric. So this is telling us for each text how similar or dissimilar it is in meaning to each of these word groups that we have. So you'd expect texts that are much more about science, technology, and research to score highly on this metric. So it'll be between -1 and +1, just like a correlation. And even just looking at these TED Talk titles, you can see that the ones that are up here at the top seem to have more science and researchy type titles for the TED Talks. How animations can help scientists test a hypothesis, how do you explain consciousness, things like that. If we go to the low end, I would expect these to be more maybe humanities or art or things like that. Okay, these all have really low word counts, so I'm going to scroll up a little bit. Things like, let's see, what are these? Love letters to strangers, how to live to be 100, turning trash into toys, kids need structure. So things are probably less obviously scientific. And of course you can go in and actually read the texts to get a sense of how well this is actually working. For the most part, in my experience, it actually is a pretty solid method and works pretty well. But it depends heavily on the Word2Vec model that you're using. So if you're using a pre-trained model that comes from something like Twitter data, it's probably not going to work as well as something that was trained in a much more congruent context. So here I'm using a model that was trained on the same data that I'm actually analyzing. So the semantic space is a pretty good fit. And generally speaking, the further away you go from the context of the texts, the worse, kind of the weirder results you'll get. It won't fit quite as well. So keep that in mind if you're using pre-trained models that other people have made, like some of the models that Google or Facebook have out there. Keep in mind what the original source texts were. And I think that that's it for the Word2Vec plugin. That should be pretty much everything you need to know. In the future, there's definitely going to be some other stuff that you can add. I might also add some additional plugins that use other algorithms and not just the very popular Word2Vec algorithm, maybe latent semantic analysis, but time will tell.